we are going to be discussing the intermediate value theorem. We'll discuss the definition and we will see how we can use it to decide if there is a zero on a given interval for a continuous function. Then we are going to use a TI-83 or 84 graphing calculator, you can use either, to approximate the zero correct to 2 decimal places. So the first thing we want to do is we want to define the intermediate value theorem and look at what that means. So intermediate value theorem, it states let f, which would be our function, denote a continuous function if a is less than b and f of a and f of b are of opposite sign, then f has at least one zero between a and b. So we're going to look at the example below where we have a function defined that is 2x cubed plus 4x squared minus 6x plus 2. So we have a polynomial function. It is between -4 and -3 is the interval we are interested in. So this is polynomial. We know that it is continuous. It's a good idea, always to check these things, just to make sure that all of your conditions are being met. So we're going to look, I've already set this up in my graphing calculator. I have some instructions down here. You want to enter your function into your y1. I'm going to show you that in just a minute. We'll graph the function and we will select an appropriate window just to review a couple of basic TI skills. I am using a TI, it looks like the SmartView CE. It's the TI-84 Plus. But you can do the same type of analysis, and the same functions are going to be on your TI-83. So if you're on your home screen, what you want to do is you want to hit your y equals key up here. So the y equals, you can enter your function, just make sure that you're putting your exponents where they go and everything looks correct. Now, if I don't know the window, we do know it's polynomial. What we can do, I like to do a zoom standard. So on my calculator, that's going to be the 6 under the zoom button. And this just gives me a good 10 by 10 window, so -10 to +10 in both my x and y directions, so on both axes. And you can see I get a pretty good idea of the function, but I am missing a little bit up here. So I'm going to expand my y-axis up a little. So going to my window, I'm going to increase it. And as I said, 10 by 10, or -10 to 10. I'm going to change my y to 20. And I'm going to try graph again to see how I did. Okay, I'm pretty happy with this. So I think this is a pretty good window. We can see our function. Now, really, we're just interested in this part right here, but I just like to see it anyway. So my function, the interval we're interested in is right here between negative. So this is -1, -2, -3, -4. So it's going to be between here and here. And it looks like indeed there is a zero. But we're going to try and prove this using the intermediate value theorem. And then we will come back to our calculator to do some other applications to find and predict that zero by approximating it with our table. So first, what I want to do is I am going to identify my A and B. So the A and B are going to be the boundary, the endpoints of our interval that we're given. So I'm going to go ahead and zoom in a little here, and we're going to do some work on the whiteboard. We have the function that we just discussed, and we've been asked to identify whether or not it has a zero. So I'm going to say this is my A, and this is my B, and -4 is less than -3. So we've met that. We saw that it's a continuous function. So to decide if it has a zero, we're now going to plug in my f of A, which is going to be f of -4. And remember, when we are plugging into values for functions, when we're evaluating a function at a given value, we want to use parentheses. And you could do this on your calculator too, I suppose, since we've already typed it in. I am going to type this into my graphing calculator, and I'll show you that. I've already done that on the screen. If you may have noticed that a second ago. And then I'm also going to do the same thing here for my f of b. So I want to plug in both my -4 and my -3. Just for the time's sake for the video, I'm going to go ahead and set up both equations. And what we are going to do, we have this. I'm going to ask you maybe to pause the video, go ahead, write out this, go ahead, plug it in your calculator, see if you get the right values. If you want, maybe look at it and think about what that's going to mean. And when you're ready, go ahead, unpause it, and let's see how you did. Okay, so we are now going to go over, I'm going to show you these two equations typed into my calculator. And I have them right here. So when I plugged in -4 to my function, I obtained f of -4 is equal to -38. For my b, my f of -3 obtained a value of 2. So hopefully those are the two values you got. If you didn't, double check what you entered versus what I have here on the screen. Look for any errors, because these are the type of things you want to correct, prior to like a test or anything of that nature. I'm going to come back over to the whiteboard and I'm going to plug in those two values we got. So for my f of -4, my calculator returned a value of -38. For my f of -3, I saw that the function is equal to 2. Now, what does this mean in terms of the intermediate value theorem? I'm going to zoom out a little bit. Think about this. My f of a is then equal to, I have a little stray mark there. Going to be equal to -38. Notice this is less than 0, right? And for my f of b, or my f of -3, that was equal to 2, which is greater than 0. So by the intermediate value theorem, we have shown that f of a and f of b are of opposite sign. One is less than 0, one is greater than 0. So this is negative, that is positive. So we can then conclude that there is at least 1 0 between A and B. And we had a pretty good feeling about that because we looked at the graph ahead of time. But I like to show you that just to help you see. So we can say, therefore, there is, and again, it's at least. So there could be more than one, at least 1 0, right? So we can conclude that it does indeed cross the x-axis to change from negative to positive. So on our graph of our function, let's just take a quick look at that one more time. Let's see what it looks like. So going back to my graph, do you see how down here my y values are negative, up here they're positive? So in order to have a 0, your graph, your function is going to have to cross the x-axis. And when it does that, you will have a sign change. And so that's really what the intermediate value theorem is saying. It's saying, hey, if I have two numbers, I know that the value of my function is negative for one and positive for the other. And logically, that makes sense. It's going to have to change. It's going to have to go through the 0 to move from negative to positive, as long as the function is continuous. So you see how all the rules that we had written out really make sense looking at that. Okay. All right, so now we're going to look at the second part. We're going to take what we had and we are going to build on that. So if we have, if we have, at least 1 0, we can use our graphing calculator to approximate that 0. So that's going to be the second part of this problem. And I have several slides that we're going to work through together. We're going to be moving back and forth between our whiteboard and our graphing calculator. Now, I've written out some instructions. I have some screens here to help us, but I am going to show you the keys on the calculator as well, just to make sure you're comfortable. So we're on this second part where we're approximating the 0 to 2 decimal places, it does ask us for the truncated value. So this is not the rounded value, and there's a difference. And when you see the answer, there's an explanation. So I just really wanted to kind of emphasize that up front. We're going to use the table feature on our calculator to approximate. And I have listed the steps and the commands that we want to do. I've also kind of shown you the window. So I'm going to walk us through this little explanation. We're going to maybe go over to the calculator, practice putting that stuff in. We're going to look at our table of values, and we're going to talk about this. Now, this is a iterative process. So what that means is we're going to repeat this process. We've been asked to approximate the 0 to 2 decimal places. So we need to go from having an integer, which has a ones place, to having 2 decimal places in order to approximate as we have been asked to do. So here, we're currently, if we look at, like, say our A, it's -4, and we need to have 2 additional places, okay? And it's really going to be in terms of our B value, which you will see as we get a little further, and I will explain a little more detail. But it's going to be between -3 and -4, the value, because we have decided that already based on our prediction using the intermediate value theorem. So to go ahead and begin, we will use the table feature, as I mentioned. In order to use it, we first must set it up so that it gives us the values we're looking for. So because we have -4, -3 as our two given values, and that's where we predicted our 0 would lie, we want to take this and we're going to split this into 10 even intervals. So we're going to take our table. We want to start at the smallest value, our -4, our A value. And then we want to increase so that after 10 values, 10 increments, we are at our endpoint of -3. In order to decide how many spaces we should go up each time, what we're going to do is we are going to take those 2 values and we're going to divide them by 10. So we're going to take the difference. And to do the difference, we're going to take B minus A, so -3 minus -4, which conveniently gives us a +1. Divide that by 10 to get 0.10. And if you're not sure, just plug that in your calculator and you'll see how that works. And really that makes sense because we want to go from -4 to -3. We want to go down to the next decimal place, right? We want to have something, like we said, in the next decimal place. And then we're going to repeat this process one more time to get 2 decimal places, just to give you an idea of where we're going. So when we get into the calculator, this is the menu we want to see. And we want to enter the values just like I have here. So let's go ahead and do that together. Okay, so we are going to come over to our TI-84. I still have my graph up from the last example we just did. Now my table set is a second function. So second is in blue. These second functions are above the key you will hit. It's in blue as well. So I know to do second, and I'm going to hit the window key to access the blue table menu. Okay. I want to start my table at my lower bound of -4. I'm going to increase by 0.1 each time
You
to
are currently
reach
the only person in this conference.
-3 by the time I arrive my 10 steps. So I'm going to go ahead and do second table. And now you see I have -4. I'm going to move up, and -3 is my endpoint. So I have the function values, the y1, for each of those corresponding x values. Okay. So looking at this, looking at our table, what we are trying to look at is where does it change? Where do my y1 values change from negative to positive? Because that's going to help us drill down where the 0 lies. So if I look at this table, do you see between the last 2 values, your y1 goes from -0.542 to +2? It corresponds to the x values of -3.1 and -3. We're going to keep these values, and these are going to be the 2 new intervals, my new A and B, okay? So we're going to come back over to the whiteboard, and we're going to use this information. So we just completed this work, and now I'm coming over here. So this is the table we just had, and so what we are looking at, we looked at our y1 values on our table. We wanted to identify where my function changes from negative to positive. Well, we see that change occurs right here, right? Y1 changes from a negative value here to a positive value here. So that means my 0 has to lie between negative 3.1 and negative 3. This is going to be the new boundary values that I want to use, okay? So that's going to be my new A and B. And now that we have those values, we are going to repeat this process one more time. So again, I prepared this a little ahead of time because I knew what was coming, just to make it a little better for us as you're watching this. So I have these two new values of negative 3.1 and negative 3. I'm going to once again use my table feature and that menu. I'm going to start at the new A. So make sure you replace your A with negative 3.1. And then in order to drill down to another decimal place, I mean, and it makes sense when you think about what we're trying to do. We found one decimal place, now we need the second decimal place. But you can see that we're getting it by taking our, and actually I wrote this backwards. This should be negative 3 minus negative 3.1. So I actually have an error here in my slide, and I will correct that for you right now on the screen. So see, okay, as long as we catch our mistakes. So what we're going to do, let me turn this on and I will fix that for you right now. So this should actually be, make sure that you're doing B minus A. So this is actually going to be negative 3 minus negative 3.1. And when you do this, this is going to actually make this positive, right? And you'll get 0.1 divided by 10, or 1/10 divided by 10. And if you take a tenth and divide it by 10, you will end up with a 100th. So we're going to be changing the values between negative 3.1 and negative 3, and we're going to go up by 100 until we reach there. That's going to give us those 10 equal subintervals that we want, okay? So when we get to this menu, negative 3.1 going up by 0.01. So let's go over to our calculator and do it one more time. Okay, so this is our picture from last time. And once again, I'm going to access second table set to change the settings for my table. We said negative 3.1. That's our starting value. We want to increase. We're drilling down to the next decimal place. So it should increase by 0.01. And I don't mess with these two down here, so please don't change those settings. We're going to leave those alone. The default settings are correct. And then again, second table. I didn't really emphasize that the first time, but you are going to hit second, your graph key, in order to access the table menu. Now we do want to look at this and make sure we've set it up correctly. We have our negative 3.1, and you can see that it's increasing by 100th each time until it reaches negative 3, which would be 0.0. Okay. Looking at our Y1 values, just like we did last time, once again, we're looking for where do they change. And do you notice here, they change between negative 3.08 and negative 3.07. Okay, so those are the values that we want to keep. Those are the values we're going to use. So we are nearly done with this problem. All right. And again, I apologize for that error. Just make sure that you've got that correct. Now, one more time, let's come over here. I do have our table here for us. So looking at that table, just like we did when we were looking at it on the calculator, what we are looking for is where do my values change? And I'm going to zoom in a little to make it easier for us to distinguish. Let's go ahead and pull this over. So where did my function values change? So my function was negative here, right? And then it changed to positive right here, okay? So we are interested in the interval between, it's going to be negative 3.08 and negative 3.07. Okay, so we are nearly done with this problem. So remember at the beginning I mentioned that truncated word? So if we were talking about rounding, maybe if you were going to round, you could round at this point to like 3.1. We're not rounding, we're truncating. But let's talk a little bit about if our zero lies between negative 3.08 and negative 3.07. What are the numbers that are between those two values? Well, if I were, and again, I'm going to zoom in real quick so we can just kind of see this. I'll make a little number line here. So say that we think about it as if this is negative 3, sorry, 3.08, and this is negative 3.07. What's between them? Well, you have, actually it probably needs to be bigger, negative 3.071, negative 3.072, 3, 4, 5, and so on. I'm actually going to list this because it's kind of weird seeing it like that. Negative 3.08. So think about it like 80, and think about this as almost like 0.70. So then you're going to have 3.071, right? And you'll have negative 3.072. And we've decided that it has to happen between these two endpoints, right? So do you see how like every digit in here, if we cut it off, it's always going to be negative 3.07. So when you truncate, you drop off anything behind it. That's really what that means. It's always going to start with negative 3.07. So when you're returning the truncated value, you're going to be returning your B, which is going to be, in this case, negative 3.07. Okay? And that is the end of our problem. Please let me know if you have any questions or any feedback.